Okay, guys, today we're going to talk about transformations, such specifically rotations. A rotation is a transformation that rotates a figure about a fixed point through a given angle and direction. For example, 90 degrees clockwise. Now, we watched a video the other day which explained the rotations with positive degrees and with negative degrees. We're not going to do the negative concept. We're just going to think of it as clockwise or counterclockwise. All right? So remember, clockwise is rotation to the right. Counterclockwise is rotation to the left. Okay? The official degree, the way that you would start out if you were learning about degrees in rotation, you would always start out with the counterclockwise version. Okay, that's just how the positive angles work on the coordinate plane when you're measuring angles. Now let's take a look at the 90-degree clockwise about the origin rule. Alright, so just like we saw rules for reflections and translations, we also have rules for rotations. There are like 3 rules that we have to learn, okay? But there's like some redundancy. There's like some things that it says the same thing more than once. So you have to know how to match these things that are the same. You have to match them up. So the rule is that we're going to change the sign of X and swap the order. Change the sign of X and swap the order. So for example, we'll see some examples in a minute, but I'll put a simple one here. If we had 2 and 4 for our X and Y, what we would do first, and this is just so you don't mess up, change the sign of the X. Go ahead and do it mentally or on your paper or wherever. So I know that's going to be a -2. So that -2 goes over here. And then the 4 stays the same. But you're just swapping them. Okay? Just got to be careful. Just like on the quiz yesterday, when we went back and did our corrections, a lot of you got them right because you saw what you had done wrong. There were some just simple things that you missed. Now, the 90-degree clockwise rotation is the same as the 270 counterclockwise. Let me show you 90 degrees clockwise. 90 degrees clockwise is moving, or counterclock, I'm sorry, I said that wrong. 90 degrees clockwise, you always start right here. 90 degrees clockwise is this angle right here. So if I were to go 270 degrees counterclockwise, that would be landing on the same side, if you will, the same part of the coordinate plane. Okay? 90, 90, 90 is 270. 90 times 3 is 270. Okay? So, that's why these two angles have the same rule. It puts you in the same place. Alright? Let's move on. Rotate 90 degrees clockwise about the origin. So, good, guys, it's just about using the rule. That's all it is. Alright, so I'm going to change the sign of X and swap the order. So when I change the sign of X, what does it become? +7. And I need to put that second. And then the Y value goes first. So it becomes 3/7. Okay, again, you're not going to have to memorize these rules. I'm going to let you use them. When you had Coach Rankin's class, you had to memorize them, right? He didn't let you use the rules. Well, you know what? We're doing this for the second time. We've seen it. I'm not going to make you memorize them. We're going to go ahead and have the resource there and hopefully just be able to use that resource. All right, so what do I do with the 1? Swap it and change it. Okay? So it becomes -1 in the second place. What about the 4? Same. Alright. So what's C prime going to be?
1/3.
Excellent. There you go. Alright, so that's how you do 90 degrees clockwise about the origin. When it says about, it really means I'm rotating around About and around in this case mean the same thing. So the origin is like my point of rotation. So if I had a figure right here, I would be rotating that figure. See if I can do it. I will be rotating that figure. It's not going to let me do it. Oh well. About that origin. Maybe I can do the whole thing. Hold on. Alright, so see how, just imagine I rotated that thing, I just rotated it 90 degrees counterclockwise. That's 180 counterclockwise. That's 270 counterclockwise. And now it's 360. That's back where I started. Okay? I'm moving around that center point, the origin. Okay? Alright, rotate 90 degrees clockwise about the origin. Same deal. I'm going to take each of these coordinates and use the rules. Now, I'm giving you the coordinates here. But I wouldn't have to give you the coordinates. You could just be required to determine what those coordinates are on your own. So, let's see. This point, all right, is 1, 4. That corresponds to point B, what they're calling point B. So I'm going to put a B right here. All right. This point over here is -7, 3. That corresponds to A. And then the last point over here, point C, is 3, 1. That's point C. Now, again, I don't have to give you the coordinates. You can look at the graph to determine the coordinates. There will be times when you have to do that. There could be times. All right, so then we just use the rules. All right, so what is the rule, or what are we going to do with this first one? This is the same, these are the same ones we just did. Okay, so it should be 3, 7. It should be 4, -1. It should be 1, -3. Okay, all right, now if I wanted to graph those, I can come over here and I can graph those. 3, 7, to the right 3, down, up 7, right here. Okay, that's A prime. And then to the right 4, down 1, that's B prime. And then to the right 1, down 3, C prime. Connect those. And we have the rotation. Now, I want you to notice that if you understand a few of the things of just simply about the concepts of rotations, you can kind of get an idea of where it's going to be before you ever do the graph. If this thing is in this coordinate, if this A value is in this not coordinate, quadrant, if it's in this quadrant, this is the second quadrant, and we rotate 90 degrees clockwise, it's going to be one quadrant over, because 90 degrees is one quadrant over. Same thing with point B and point C. B is in this quadrant, well, it's going to be down in this quadrant if it's a 90 degree rotation. If it was a 180 degree rotation, it would be 2 quadrants over. So instead of being in this quadrant, well, this is where it started, instead of being in this one on the 90 degree, it would be down here on the 180. Okay, so if you understand just some things about the quadrants, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We go counterclockwise when we name our quadrants. All right, you'll understand that each of those quadrants is a 90 degree. To get to the next one, you're moving 90 degrees, if you will. All right, let's look at the next slide. This is a rotation of 90 degrees counterclockwise. Now this is the same as 270 clockwise. So again, let me show you. Here's our coordinate plane. If I'm going 90 degrees counterclockwise, I'm going to land right here on this part. That's 90 degrees. Okay, remember the little right angle symbol? Okay, that's what I have. All right, if I go 270 clockwise, that is from here up to here. It's the same endpoint. All right. So 90 degrees clockwise, counterclockwise, and 270 clockwise are the same. All right. We use CCW for counterclockwise, and we use CW for clockwise. All right. Here's the rule. We're going to change the sign of Y and swap the order. Change the sign of Y and swap the order. When we do that, we will end up with something similar to what we had before, but it's just the opposite, if you will. All right, so let's look at some examples of this. Okay, so we want to change the sign of Y and swap the order. So the -3, the x value, it doesn't change. But the -2 will be the opposite. So what will this become? Yep. Okay, what's the next one?
-5, -6.
Yep. What's the next one?
-2.
There you go. It's all about the rules, guys. Yeah, I'm not making you memorize them. All right, let's move on. Okay, here's a similar situation. We got the same coordinates here. I think one of them may be wrong, actually. Let's see, where are we? Right here. Yeah. Okay. On your paper, you'll see that it's a +2 next to that -3. It's supposed to be a -2. Okay, so change that on your paper to a -2. All right, so now we do the same thing. It's the same problem. We're going to change the sign of Y and swap the order. So I'm going to go ahead and write them in. You can too. All right. Now let's graph these and just see what it looks like when we go 90 degrees counterclockwise. Okay, remember counterclockwise is to the left, moving to the left. All right, so 2 -3, and that would be E prime. Oops. And then -5, -6, go to the left 5, down 6. And that is F prime. And then -2, 0. And that is G prime. Alright, so we go there, we go there, we go there. And there it is. So again, counterclockwise is we're moving to the left. This point, starting this quadrant, went 90 degrees down to this quadrant. All right, let's move on. Okay, the only other rule is this, and this is rotation 180 degrees about the origin. This is the easiest rule when it comes to rotation because you don't have to swap anything. All you do is change the signs, just the opposite. So only change the signs of both. Change the signs of both. And that's, I mean, it's that simple. All right, so let's look at an example. -8, -2. So what does that become? All right, -8, -9. -2, -2. -2, -9. Okay, very easy. It's all about just doing what the rule says. When you get to a quiz or test, do what the rule says do. All right, don't overthink it. Just do what it says do. All right. Same ones. Again, 8, 2, 8, 9, 2, 2, 2, 9. Okay, it's a 180 degree rotation. Can you tell me what quadrant this thing's going to be in? Again, this is 1, 2, 3, 4. What quadrant? It's going to be in the first one. Because 180 degrees is 2 quadrants over. 1, 2, or 1, 2. It doesn't matter if I go clockwise or counterclockwise. It's going to be in the exact same spot. So let's graph these. 8, 2, 8, 9, 2, 2, and 2, 9. Now, if you were in Coach Rankin's class for the year, like his classes are, you would take a lot of time. I mean, y'all will be doing a lot of practice on these these problems. We would have done a lot more practice probably on reflections and translations than we did because there's more, it's a longer period of time. Okay? And you've never seen it before. But now you've seen it before, so we don't have as much time, so we're not going to do as much practice. So, same with this stuff. We could spend a lot of time practicing rotations, but we don't have a lot of time. So we're going to do similar to what we did before, and we're going to just get to the main point. All right, rotational symmetry. This is very important. When you were in my algebra class, we talked about rotational symmetry. Some of you were not in my algebra class, but if you were in my algebra class, we talked about rotational symmetry and even and odd functions. All right? An odd function is a function that has 180-degree rotational symmetry. All right? Which means if I were to turn this paper upside down, it would look exactly the same. Does it? No, everything's upside down. But if I took a paper, one of these, if I took a paper imagine that's a perfect cross over there. And turn it upside down, it's exactly the same. So this paper has 180-degree rotational symmetry. Well, this figure has more than just 180-degree rotational symmetry. Any figure that can be turned or rotated less than 360 about a fixed point so that the figure looks exactly as it does in its original position. So I can rotate this sun 1, 2, 3, 4, 5, 6, 7, 8. 8 different types of degree measures in order for it to land right back on itself because it's symmetric, if you will. So you can kind of rotate it from this one over to this one and it would be the same, right? You can rotate it from this one way down here to this one, it would be the same. There are lots of ways you can do the rotational symmetry. The way I would determine what the degree is, pretty simple. I would just need to know what that angle is. If I knew what that angle was, then I could say, oh, that's the degree of rotation. Okay? I'm not asking you for the degree of rotation. I'm just asking you to understand when an object has rotational symmetry. If it's symmetric like this, there are lots of things like this that have the symmetry. Okay? Ambigram is something that looks the same right side up as it does upside down. These are kind of weird things here. What does that say? Vegas. If you flip it over, it still says Vegas. All right? It looks exactly the same if you flip it over. So it has 180-degree rotational symmetry. Same thing with this. Can y'all see what that says? Earth. Yep, Earth. What does that say? Huh? Somebody said it. Air. What is that? Fire. Water. All right, earth, air, fire, water. In other words, dirt, air, fire, water. This is kind of what makes up the, planet. All right, and then thank you. You can see that it says thank you. If you turn it upside down, it also says thank you. So those are special little word art, if you will. Okay, here's some other things. Which figures have rotational symmetry? For those that do, describe the rotation that map the figure onto itself. All right, does this heart have rotational symmetry? No, because if you flip it or turn it in any way, it's not going to land back on itself. It's not going to match up. What about this regular pentagon? Yes, and it does because each of these angles, since it's regular, what does regular mean? Y'all learned all about polygons. What does regular mean? A regular polygon. There's something special about its sides and its angles. They are all the same. All right? So the sides are the same and the angles are the same, which means these angles are the same if we draw to those vertices. All right? So what that means is take 360 and divide it by 5, and that tells you the angle of rotation. So just like with that star earlier, take 360 divided by how many of those little points it had, that would be the angle of rotation. For this one, it's 72 because 360 divided by 5 is 72. All right, does this isosceles triangle have rotational symmetry? So this did not. This does. No, this does not. Does this rhombus have rotational symmetry?
Yes.
Yes. What is the rotational symmetry that it has? What degree? If I flip it over, will it look like itself? Will it look just like it?
Yeah.
In other words, if I take this thing and I rotate it 180 degrees, think about it this way, all right? This point is now down here, and those are similar, right? So it has 180 degree rotational symmetry. So the answer is yes. So a parallelogram is going to have rotational symmetry of 180 degrees. All right, let's stop this thing. Okay, so we've got a triangle that's in the second quadrant. If we move this thing clockwise 90 degrees, it's going to move one quadrant to the right. So what quadrant would it be in? Quadrant 1. It would look something like this. Okay? If I move that triangle 180 degrees, it's going to be two quadrants to the right, if it's going clockwise. And it would be down here, and it would look something like this. Oops. Okay, if I take that same diagram, same triangle, and move it 270 degrees clockwise, it moves three quadrants to the right. And it's going to be here. Excuse me. Here it goes. Okay, it's going to be pointing something like this. So, if you want to know the image of these points, let's say this is point A to start with. Well, this would be A prime. This could be, you call it A double prime, because it's been transformed twice. This would be A triple prime if you transform it 3 times. Alright, so to get from A to A triple prime, you would go to 7. Alright, same thing over here. If we want to go 90 degrees clockwise, it's going to be right here. 90 degrees counterclockwise up here. All right, 180 degrees, I said that one. 180 degrees clockwise right here. 270 in that third quadrant, which is the first quadrant, but it's the third quadrant over. Okay? Let's look at another slide. Okay, here we have a figure that needs to be rotated 90 degrees clockwise and 180 degrees. And you don't say clockwise or counterclockwise when it's 180 degrees because it's the same. So these are the points. These are the coordinates. You can draw the diagram if you want to, but he's given us the coordinates. So really all we need to do is use the rule. So go back to your rule. Alright? Back to your rule. On your paper you need to write rotate 90 degrees clockwise, rotate 180 degrees, and then write down what the original coordinates are. Okay? And you can do it like this. This will be our 90 degrees. This will be our 180 degrees. All right, so what do we get? When we rotate 90 degrees, we're going to change which of the signs? The X, and then swap. So this becomes, good. This next one becomes,
4, 3.
good. This next one becomes,
0.
1. And it's just about being careful, guys. Using the rules, being careful. Okay, 180 is the easiest of all. Just change both signs. You don't have to swap any order or anything. So what is this one?
4.
Good. What's the next one?
4, 3.
3, -4, because you don't have to change the sign. Or you don't have to swap. Okay? And then 0. Okay? When you change the sign to 0, you don't change anything. It's the same. There's nothing to change. 0 is the same as -0. So we're going to go ahead and change both signs. So when we do that, we get A prime is what? 32. B prime is 1, -2. Yeah, it's easy to do it. Don't swap them, just change the sign. C prime, good. And D prime, there you go, -1, 1. Okay. Looks like we swapped them, but we really didn't. We just changed their signs. Okay. Okay, so like I did before, let's draw it out like this, where we have 270 degrees counterclockwise for each of them, and then 270 degrees clockwise for each of them. And the rule for 270 degrees counterclockwise, if you go back to your packet, it's the same as 90 degrees clockwise, exactly. So you're going to change the x and swap. Change the x and swap. So if I change the x and then swap, I end up with -2, -2. Change the x and swap, I end up with -5, -4. Change the x and swap, I get yep. And then change the x and swap, you get okay, good. All right, 270 clockwise is change the y value and swap. Okay? Change the y value and swap, and what do we get when we change the y value and swap? 2. Okay. Again, change the y value and swap. We get 5, 4. Change the y value and swap. 6, 2, and 4, 1. All right. Okay. I don't. For some reason, my computer is not letting me do these. So in the diagram, the 2 degree rotations that we have for this diagram are 90 degrees clockwise and 270 degrees counterclockwise. They are the same. Okay, what about this one? How many quadrants over? It's got to be 180 because it's 2 quadrants over. Do I even have to think about it? Nope. I don't even have to know what the coordinates are or anything if they're just asking me what the rotation degree is. We're not doing like the little degrees like 20 degree rotation or 25 degree rotation. We're just doing 90, 270, and 180. So this is going to be 180, and you don't have to say anything else because clockwise is the same as counterclockwise. It's just 180. Okay, what about this one? This is a little different. All right, look at A prime and then look at A and then look at A prime. All right, A prime. What degree rotation is that? It's 90. Which direction? Clockwise. So it is 90 degrees clockwise equals 270 degrees counterclockwise. Those are the two that are the same. And again, I could go 90, 180, 270. Okay, let's look at another example. And that's it. No more examples. All right, on your packet, There are lots of problems.